fresh, shiny granite surfaces contrast markedly with the crumbly, sandy material of the matrix. These deeply weathered profiles are easily excavated. Large areas have been removed to form platforms for housing developments. Urban construction sites form an excellent laboratory for the examination of the details of granite weathering. Particular attention should be paid to variations in the depth of weathering and the distribution of core stones with changes in rock structure and the local topography. Fine examples of granite weathering can be seen at To Kwa Wan. Here, a large tor is preserved in the center of the land reclamation. This tor stands upon an island in the former bay. Alveolar weathering, an intricate network of rounded hollows, covers many of the exposed rock surfaces. Large angular blocks of granite mark the outer coastline of the former island. The processes of weathering produce, over time, thin soils on these volcanic rocks. You can observe closely spaced joints near the top of the parent rock formation and see evidence of rock breakup. Only hardy species of plant tolerant of thin acidic soils and dry winters can cope with the environment of weathered granite. A sandy matrix forms the parent material. The sandy matrix can be easily eroded, soil is lost, a patchy vegetation cover remains. This is an extreme environment for trees. On these slopes of weathered granite, trees and shrub vegetation tends to concentrate in the wetter valleys. Here, the eroded soil material accumulates to support these shrubland ecosystems. Vegetation patterns tell a story. Variations in vegetation density, composition and biodiversity are related to topography, soil and drainage conditions. The vegetated hills and valleys of Hong Kong's country parks, like this one seen here at Sai Kung East, have an important role to play. They provide catchment areas for our vital clean water resources. The High Island Reservoir and its adjoining country park serve many functions, of which water capture and passive recreation are outstanding. On the extensive volcanic soils of the Sai Kung Country Park grow some outstanding plants. The Chinese New Year flower is such a plant. Vegetation on exposed coastal sites experience strong winds and exhibit a wind-deflected growth form. On the weathering faces of these volcanic rocks, one can find habitats for plants and animals. A fern has established a hold here, where it too can contribute to the biological aspects of weathering. A large lizard occupies a neat space in a weathered rock joint. Micro-weathering processes on this rocky seashore have created microhabitats for marine snails. These tiny crevices are the snail's link with survival, especially at low tide, when wind and sun can desiccate the stark rock. At high tide, the crevices can help the snails cope with wave action.
We've been out in the field for a long time now, and I think it's time that we came with our ideas from the field into the laboratory. We'll take some samples from the field and we'll have a look at them. Right here I've got a nice piece of fairly dry mud collected from Saiwan. We did a little bit of work out there earlier. And we're going to take this mud sample, we're going to break it, we're going to put it in this beaker here, and we can see that it's not just a simple piece of sand or sandy mud. It will require some work. This sand sample from Saiwan is not just simple sand. There's different zones in the sample, and where you can see the pen, there's a dark zone, and this is anaerobic, and this old, dead organic matter working its way in the sediments. And to study this in the laboratory, we need to break the sample up. We've brought this sand sample in from the field, and it's now in a beaker. And very soon we're going to use an important technique which involves these very nice, shiny sieves. A nice lid, and here's a very big mesh. And as we go down the sieves, the mesh gets a bit smaller. So what we're going to do now is put them back on, tip our sand sample in, or you'll be doing this in the lab, a generous application. We'll leave some aside, put the lid on, hold firmly, and then it's a shaking technique. The students enjoy this lab very much. After a period of shaking, we can then analyze the sand to see what the size distribution of the particles is. Here we have an excellent piece of what is known as Yuan Long marble. This was a core sample taken from under Yuan Long town that exists today. And the town, in a sense, is built on marble. You might have remembered from an earlier map that we showed where the sedimentary material such as marble is distributed in Hong Kong. What a fantastic sample this is. This is another piece of Yuan Long marble obtained from the same area, but of course this is a square one. Looks more like a valuable stone. We need to take a close look at small pieces of marble, and we can do this in the field with a fairly old-fashioned hand lens. It's still very useful, but when we come back to the lab, we use a binocular scope. And we can put a small specimen of marble or other rock underneath this and have an excellent close look at it. I know you'll enjoy doing this. As you know, we have maps, geological maps. There's an excellent one here by the Hong Kong Geological Survey, and you'll use this map in the lab. And of course, that map records different types of rock, such as this. Now, if you really want to get inside this, it's not an easy job at all. We have to take a very, very thin section of a rock sample such as this. And if we do that, we can end up with a piece of rock, slice of rock on a glass slide. And the next step is to take this slide and place it under this polarizing microscope, a very expensive piece of equipment, and can give us a whole new perspective on rocks and their detailed structure, their mineral components, and so on. I think you should look forward to doing this very much in the lab phase of this course. We've come to the end of our tour of the Hong Kong landscapes, the dynamic landscapes of Hong Kong. We finished the tour in the laboratory, and it's the right sequence. We hope, though, that now that you've done this course, you will continue to study earth science in your own way, and you will continue to enjoy Hong Kong as a place with outstanding landscapes, and try and think deep in what lies behind the rocks of Hong Kong.